countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And good evening to all teachers, parents, and my wonderful student. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with eDidik Malaysia and Kelab Guru Malaysia with the hashtag Bermula Percuma, Selamanya Percuma. Before we proceed, let's begin our session today with the recitation of Kitab Al-Fatihah for the Muslim. And for the non-Muslim, please take a moment of silence. Al-Fatihah. So how's everyone doing today? My prayer is that everyone is in the best of health and ready to proceed with today's class. Let me introduce myself first. My name is Nun binti Muhammad Noh. You can call me Madam Nun or Cikgu Nun. I am from College Matrikulasi Negeri Sembilan. So it is a very special class today because I will present it alone. Okay. So before we start our discussion today, please subscribe to my channel so that you will not miss any of my new video in the future. As usual, the lesson will last approximately for 1 hour. So the certificate link and the credit claim link will be given at the end of this lesson. So you can only use eDidik email and MOE email to claim the certificate. Okay. So I will put the link to apply the eDidik email in the chat box now. So those who do not have the email eDidik, you can apply now. Okay. So hi everyone. Hi Chia Ying. How are you? Okay. So the link is there. Be sure to follow the class up until the end and give your full cooperation in making this lesson a lively one. So I would also like to remind all of you to use appropriate language and use appropriate profile picture if possible. Your own picture, of course, if you wish to post comment in the chat box. I am pretty sure that all of you here are excellent students who will uphold a positive classroom environment. So stay focused, and if you have any question, please write in the chat box. So without further ado, I will announce now the first letter and together with the 2-digit code for the credit claim. Okay, so the first letter and the 2-digit code is A18, A18 or A18, A18. Okay, so make sure that you jot down somewhere the credit claim. So you need to wait until the end of the class to get the complete code. Okay. All right. Now I am going to open my slide. Okay. So, okay, if you look at my slide, this is, I want to introduce you the teams that we have in the Academy YouTuber. So here are the physics team. So for the physics pre-U, STPN and matriculation, lead by Madam Rosmaya. There are Teacher Sue, Teacher Ayu, and also me here. Okay. And then we also have mathematics team, okay, lead by Teacher Im. Okay, and then there is a biology pro-U team lead by Cikgu Faiza. Okay. And then we also have a chemistry team led by Cikgu Shahnun. And we have the Perakaunan and Ekonomi Prayu team, okay, led by Madam Fizi. Okay, that's our pre-U and matriculation team. Okay, now, actually, Academy YouTuber also have apps where you can download it from the Google Play Store. Okay, there are a lot of video there, including the physics video. You can refer to the apps. Okay, you can download and refer to the apps. So now we have come to the main objective for today's class. So what is our learning outcome, or what is our objective for today's class? So for today's class, we will discuss the problem solving for the topic 1, which is about the electrostatic. So this is for the matriculation. It is the for semester 2. Okay. So take a look at the first question. Okay, at the same time, actually, I will also explain about the few concepts that relate to the topic, to the subtopic that I discussed. Okay, and you also can take a look at the link that I give to you in the comment. A link of the question. You can try and we can discuss the solution. Okay, so uh, for question number 1, okay, state the Coulomb's law. Okay, this is the main law in the electrostatic. So how you want to explain about the Coulomb's law? Okay, so actually Coulomb's law explain about the if you have 2-point charge. Okay, so if you have 2-point charge, let's say Q1 and Q2, with the distance between them R, so there is a force exerted on each charge, okay? And if the sign of the charge, because of there are two types of charge, right? Positive charge and negative charge. If the sign of the charge is same, so the repulsive force will exerted on the charge. And if the sign of the charge is in the opposite sign, it is attractive force. Okay, so we can identify the direction of the force following the types of charge, types of these two charge. Okay, so the types of charge identify the direction of the electric force. Okay, but what is the magnitude of this force? Okay, so this magnitude of this force is explained by the Coulomb's law. So Coulomb's law state that the magnitude of the electrostatic, or we also call Coulomb force or electric force, between the 2-point charges is proportional to the product of the charges, okay, and inversely proportional to the square of the distance between them. Meaning that Coulomb's law explained about the magnitude of the electrostatic force. The sign of charge or the types of charge give the direction of force, because of force is a vector quantity, right? Okay, so instead of this statement, you also can write down the related equation, such as, because of it stated that the Coulomb force is directly proportional to the product of the charges. So the product of the charges is Q times Q. Okay, not the sum of the charges. Yeah, please be careful with that. If sum, you need to add the magnitude of the charge, but in this case, it is a product of the charges and inversely proportional to the R square. So 1 over R square. Or in the form of equation, we can write down that the Coulomb's law as F is equal to KQQ over R square. So meaning that from the Coulomb's law, you can identify the magnitude of force. And of course, because of force is a vector quantity, for the direction, you need to refer to the sign of charge. And if you look at the equation also, it is involved 2 charges. Okay, meaning that if you have 3 or 4 system of charges, so you need to identify each 2 charges, between the 2 charges only. Okay, so that's the Coulomb's law. Okay, now let's take a look at question B. Okay, so for question B, we need to calculate the Coulomb's force between the 2 alpha particle separated by the distance 3.2 times 10 power negative 15 meter. Okay, so referring to the question, this is alpha particle. So stated here, alpha particle is equal to 2 electron. Okay, the charge of the alpha particle is equal to 2 electron. So I always suggest that when you want to solve the question, especially relate to actually all types of question, I am focused on the electric part. So list the information given because of it is a lot of hidden information from the question. For example, in this question, of course, alpha particle is given as a 2 electron. So we have the hidden information, which is the charge of electron is given by 1.6 times 10 power negative 19. You can get it from the list of selected constant given to you during the exam, for example. And then because of that, the charge of the alpha particle is equal to 3.2 times 10 power negative 19. So this is considered hidden information for you. Okay, hidden information. And just write down the distance given in this case in the meter, okay, in the SI unit, and we want to calculate the Coulomb's force. So for this case, what equation that you can use? Okay, if you want to see the figure for this question, you can sketch the two charges, which is two alpha particle, okay, separated by R, given R there. And then if you want to calculate the Coulomb force, we use the Coulomb's force equation. F is equal to K QQ over R square. And then you just need to substitute. And in this case, because of both is alpha, okay, so we have calculated the magnitude of the alpha particle, which is 3.2 times 10 power negative 19. Q is alpha is 3.2 both, okay, and then the distance. Don't forget to square the distance between the charge. Okay, this part students always miss to square the distance. Okay, so if you try to calculate, you will get the answer. If you calculate correctly, you will get the answer for the Coulomb force, which is equal to 19 Newton. And don't forget that the force is a vector quantity. So even it just stated for you to calculate the Coulomb force, you need to mention the direction of the force because of it is a vector quantity, right? Okay, so you can mention the direction is to the left, referring to the diagram. Sometimes if you sketch the diagram and you show the direction of force there, if you forget to write down the direction of the force, it is okay because of you have shown the direction in your diagram. That's the advantage of sketching the illustrate the question. Okay, what the question want. Okay, is it clear? I hope that clear. So we go to the question number 2. All right. So question, I just follow our syllabus. Okay. So after the Coulomb's force, you will learn about the electric field strength. So in this case, I just want question number 2 to introduce you the what is the electric field line. Okay. So figure below shows two isolated charge, positive Q and negative Q, of equal magnitude and placed near each other. You sketch the electric field line produced by these two charges. Okay. The clue here is it is placed near each other. Even it's stated that it is a isolated charge, but it is placed near each other. So you need to consider the distance between the two charges when you sketch the electric field. So generally for the electric field line, okay, or the region around the charge, so electric field around the positive charge, the direction is outward. Okay, if the charge is isolated charge, only one charge, for example, only positive charge, so the direction of electric field is outward. Okay, from the point charge. If the charge is negative charge, so the direction of the electric field, because electric field is also vector quantity, so the direction is inward. Okay, if the positive charge, the direction of electric field is outward. For the negative charge, the direction is inward. But if these two charge is placed near each other, so what happened to the uh, electric field line? How we want to illustrate? How you want to show the electric field line that produced between these two isolated charge that place near each other? Okay, take a look at the diagram. Okay, so this is the pattern or the electric field line that will produce around these two isolated charge, which is placed near each other. It is very important. If it is a point charge only, if it is a single charge, the direction of the electric field line is only direct, and for the positive charge is outward, a straight line, which is outward, and for the negative charge is inward. But because of it is both placed near each other, so the pattern, if you look at that, we can say that electric field line will start from a positive charge because of the direction is outward, right? So they start from the positive charge and end at the negative charge. Okay, and this is a few characteristics I just write down. It is a lot. It Many characteristics of the electric field line. So the two electric field line never intersect or cross each other. So this is very important for you when you sketch the electric field line. Make sure that it not cross the between each other, no cross between the electric field line. Okay, no intersect between each other. So in the case of single charge electric field line end at infinite. So this is, as I said, if a single charge, positive charge, the direction is outward, so straight line outward until infinite. Or if it is a negative charge, it is a straight line from infinite to the negative charge inward, the direction is inward. And this line never form a closed loop, of course lah, because of the from the positive outward, inward is negative charge. Okay, they will not form a closed loop. Okay, so at the same time, you need to understand how to sketch the electric field line. And if the magnitude is different, for example, because of this is the question said that equal magnitude. So the number, if you look at the number of field line around the point charge is equal between the positive and negative charge because of the magnitude of charge is equal. Let's say if the magnitude is not equal, the field line is depends on the magnitude of the charge. Okay, the number of field line around the charge is depends on the magnitude of the charge. Okay, so that's question number 2. And for question number 3, this is the calculation. Just now it's the concept of electric field line. So for question number 3, you need to determine the electric field strength at point X 20 centimeter from a point charge Q, which is equal to positive 8 microcoulomb. Okay, I just list the information. If look, take a look at the information given here. Okay, there is a hidden information, of course, which is the Coulomb's constant K, 9 times 10 power of 9, given to you in the list of selected constant. And then Q, the magnitude of Q is positive 8 microcoulomb. The distance from point X is 0.2 meter. I changed to the SI unit for easier calculation. And we need to calculate the electric field strength at point X. So if you sketch the diagram, it will help you. For example, this is Q, and then the point X is at the distance of R from the charge Q. And okay, from the sign of the charge given, you can identify the direction of E. Because of this is positive charge, as I said just now, for the positive charge, the direction of E is outward. So at point X, the direction of E is away from the Q. So it is depends on the position of the point that we want to calculate the electric field strength actually. So it is depends on the position. Luckily, point A, X is located at the right side of the Q. So E is to the right. Okay. To calculate the electric field strength, so we know the equation for the electric field strength, which is E is equal to K Q over R square. Okay, please differentiate. Make sure that you can identify the difference between the Coulomb force with the electric field strength equation, because of both is vector quantity, but the calculation or the equation, the derived equation that we use is different. Okay, so for the EX, KQ over R square, so we just substitute. All right, do take note that luckily in this question, the point charge given is a positive charge. So let's say if given the negative charge, no need to substitute the negative value negative. Okay, no need to substitute the sign negative in the equation, because of the sign of the charge is to identify the direction of E. Okay, not the magnitude. To calculate the magnitude, we ignore the sign of charge. Take note about that. After this, we will discuss also the scalar quantity. So it is different. For the vector quantity, to calculate the magnitude, we not substitute the sign of the charge. Because of sign of the charge, we use to identify the direction. And in this case, if you calculate, so you will get that the EX is equal to 1.8 times 10 power of 6. And of course, the direction I just mentioned here, to the right. Okay. So, or if you not mention to the right, you can sketch the diagram. Okay. And then, understand, right? Now we go to the question 3B. Okay, for question 3B, where we want to calculate the electric force that act on a point charge Q, which is the magnitude is -1 microcoulomb placed at point X. Okay, meaning that the same situation, but this time we put the a point charge, negative point charge at point X. So how we want to calculate or determine the electric force? Before this, you learn about the Coulomb's law, right? Coulomb's law explain about the magnitude of the electric force that exerted on a charge. Okay, but in this case, because of initially in A, we have calculate the EX, meaning that we have calculate the electric field strength at point X. Okay, so to calculate the electric force, okay, we can use the definition of the electric field strength, which is the definition of electric field strength is EX is equal to F over Q. Okay, so we want to calculate the electric force. So F is equal to EXQ, and we just need to substitute the EX. EX we have calculated earlier in A. Okay, we can use it. No need to use the Coulomb. You also can use the Coulomb force equation, but the calculation is quite long. So for the concept, because we have the magnitude of electric field strength at point X, so you can use the definition of the electric field strength, which is E is equal to F over Q, and then you substitute, and you will get the electric force that exerted on a point charge Q that placed at point X is equal to 1.8 Newton. Okay, and the direction is to the left as shown. Because of how we identify the direction of F, because of Q, a positive and negative charge is attractive force. So the force that exerted on the point charge Q is directed to the point charge. Okay, point charge given. Okay, so this is to show the application of the relationship between the electric force and also the electric field strength. Okay, and then we go to question number 4. Okay, for question number 4, figure show 2-point charges. Okay, Q1, which is -3. Q1 is -3. So I just here is negative charge, -3 microcoulomb, and Q2 is +7 microcoulomb placed at point C and B. Okay, as shown in the diagram. So we need to determine the resultant electric field at point A. Resultant electric field at point A. Okay, because of this is 2-point charge, two system, two consists of charge. Okay, in this system. So what we need to do first, okay, so first take a look at point A. We need to identify the direction of electric field. Okay, we need to identify the direction of electric field at point A. So remember, because of electric field is a vector quantity. Because of that, if you look at the Q1 is negative. So electric field at point A is directed, because of this is negative charge. So directed toward, in because of positive charge, E is electric field line is inward. So the direction is towards the Q1. So I just label E1. And for the Q2, because of Q2 is positive charge, so if positive charge, the direction of E is outward. So at point A, the direction of E is to the left. So I represent by E2. Okay, please take note that how we identify the direction. Okay. Now what we need to do, because we want to calculate the resultant electric field, first we need to calculate E1 and E2 before we calculate the resultant electric field. Okay, so for the calculation of E1, first we calculate the E1. So E1 is equal to KQ1 over R1 square. the distance from from point A to Q1, okay, is 0.03, which is 3 centimeter. We just substitute the value, and do take note here for the calculation of E. Okay, for the charge Q1, the charge is -3, right? But we just substitute 3 micro coulomb only, because of we want to calculate the magnitude of E1. And another thing, E1 is at the Y component, so I just represent EY. Okay, E1. So when you calculate, you will get the E1 is 3 times 10 power 7 Newton per coulomb. Okay. And then for the E2, so E2 located at X component. So we can calculate the E2 using the same equation, and we just substitute. Luckily, it is a positive charge, so we just substitute positive micro. So actually, micro, of course, when you press your calculator, make sure that you press 3 times 10 or 7 times 10 power of negative 6. Micro is prefix, okay, times 10 power of negative 6. And then divide by the distance from point A to point B is 0.04. So you will get the magnitude of the E2 is 3.94 times 10 power 7. Okay, so this is the calculation of magnitude. Now we want to calculate the resultant electric field at point A. Because of this is two dimension, yeah, resultant electric field at point A. If you look at here, there are two component X and Y. So to calculate the resultant electric field, we use the vector calculation, which is to get the resultant electric field at point A. It is we use this cert E1 square plus cert plus E2 square. We just substitute the value that we have calculated, the magnitude that we have calculated, and you will get that the EA is equal to 4.95 times 10 power 7 Newton per coulomb. Okay, and then is it enough? No, because of, remember, electric field is a vector quantity. So if you refer to the here, E1 and E2, the resultant between the E1 and E2, which is produced the magnitude of 4.95 times 10 power 7 Newton per coulomb, to identify the direction, we need to use the equation, we need to calculate the theta. Okay, so theta is equal to the shift tangent E1 per E2. Why? Because of E1 is at the Y component, E2 is at the X component. So Y over X component. Substitute the value for E1 and E2. You will get the theta, which is equal to 37 degree. And below the negative x-axis, for the direction, you're supposed to write down where is the theta represent. Okay, so in this case, if you want to make sure is it correct below the negative x-axis, referring to this diagram, if we sketch the direction for the resultant electric field, okay, the direction is as shown. Okay, take a look at the direction, and the theta, which is 37 degrees Celsius, 37 degree is here. Okay, from or below the negative x-axis. It is very important, yeah, for you to identify the angle either from the positive x-axis or from the negative x below or above the axis. Okay, identify. Okay, so actually this calculation, same if you have the force to calculate the resultant force, for example, because of in this chapter, force and electric field is the vector quantity. So the way we do the calculation is same. Normally, we not stress on the vector resolving vector, because the resolving vector you have learned in the first semester, but you need to have that skill. You need to remember how to resolve the vector if the forces or the electric field given not at the x or y component. The way the same thing you're supposed to do. Okay, all right. And then we can go to the question number 5. So for question number 5, uh, a uniform electric field exists in the space between the two identical parallel charged metal plate. Okay, the plates are 1 centimeter apart. An electron, okay, take note, electron is released from rest at the negatively charged plate. It arrived at the positive charge plate 2 nanosecond later. Okay, determine the electric field strength. Okay, so for question number 5, to calculate the electric field strength, Okay, first, as usual, list the information given, and if you refer to the information given, the distance given, the distance between the two plate is 1 centimeter or 0.01 meter, and then because of it is electron, so Q is equal to the charge, magnitude of charge for the electron is 1.6 times 10 power negative 19. This is the hidden information you're supposed to identify. Okay, and because of it is electron, we have the mass of the electron. Okay, mass of the electron given in the list of selected constant also, which is 9.11 times 10 power negative 31 kilogram. And because of it is released from rest, so hidden information behind rest is U is equal to 0. And it takes 2 nanoseconds, so nano is 10 power of negative 9 second. And to calculate the electric field strength, referring to the given information, or if you want to understand the situation, maybe you can sketch the situation. So in this case, this is the parallel charge metal plate, positive charge and negative charge, and the red line is the electric field line. Okay, same case with the isolated charge, electric field line also outward from leave the positive plate, enter the negative plate. Okay, the direction of E. Okay, and if this electron move from the negative plate, the force exerted is the electric force, electrostatic force, okay, towards the positive, because this is the electron, and it experience the acceleration A. Okay, inside the uniform electric field. So to determine the electric field strength, before we determine the electric field strength in this case, okay, we can calculate first the acceleration of the electron. Okay, how we want to calculate the acceleration of the electron? So to calculate the acceleration of the electron, because of we have the kinematics equation. Still remember that you learn in the chapter 2 in the semester 1. Okay, kinematics. To calculate the acceleration of the electron, we can use the equation of S, which is equal to ut plus half at squared, because of we have the time taken for the electron to move from negative plate to the positive plate with the distance 1 centimeter. Okay, because of that, the displacement is 0.01 meter. Initially, it start from rest, so U is equal to 0. And then we want to calculate the A. T is 2 times 10 power negative 9. So don't forget this, the square. And if you calculate, you will get the A, which is equal to 5 times 10 power 15 meter per second minus 2. Okay, that's the acceleration. Now we go to calculate the electric field strength. We will use the concept of electrostatic concept, which is we refer to the Newton's second law. Because of the force, the charge, the electron is accelerate. So from the Newton's second law, the electric force is equal to ma. Okay, because of the force exerted on the charge cause the charge to move with the acceleration a, and we know that the electric force is equal to the QE. Okay, remember E is equal to F over Q, so we rearrange. F is equal to QE, and then it is equal to MEA. Then we can calculate the E because we have the information of A. Okay, A is equal to 5 times 10 power 15. We substitute in the equation. And then if you calculate with the Q, substitute the mass of the electron and also the charge of the electron. And then if you calculate, you will get the electric field strength, which is equal to 2.85 times 10 power 4 Newton per Coulomb. Okay. So this is another way to calculate the electric field strength. If you remember the question before, we use the equation of electrostatic equation, E is kq over r squared, but in this case we use the kinematic equation. Okay, so before we proceed to question number 5b, okay, before we take the break, okay, because of 30 minutes, so I would like to announce the third digit code. Okay, so the third digit code, okay, for today's class is 0. Okay, the third digit code is 0. Okay, now we break for the advertisement.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, class. We will continue. But before that, very special. Just now I announced the third digit code, right? Okay, so now I would like to announce the fourth digit code for the credit claim. Okay, so please take note, the fourth digit code for today's class is number 0. Okay, number 0. Remember the first two, the third one, this is the fourth one, and at the end of the class, I will announce the last credit digit code, the last digit code. Okay, all right. So we will continue discuss question number 5B. Okay, for question number 5B. Okay, we need to calculate this with the same question, but we need to, just now we calculate the electric field strength. Okay, now we want to calculate the speed of the electron when it arrives at the positively charged plate. Okay, so to calculate the speed of the electron, okay, in this case, the information given now, we have extra information from A, right? When we calculate the 5A just now, A is equal to 5 times 10 power 15. So to calculate the speed of the electron, referring to the same diagram, we can use the equation for the kinematics equation actually, which is V is equal to U plus AT. You need to remember this equation is not given to you for this semester, but you need to remember that you still can use because you have learned before. So when you substitute the A that you have calculated in A and the T, it takes 2 nanoseconds to arrive at positive plate. So you will get the V, which is equal to 1 times 10 power of 7 meter per second. Okay, very easy, right? But actually it is easy, but you need to still remember what you have learned before from the first semester. Okay, now we go to the question number 6. Okay, for question number 6, a 4 microcoulomb particle of mass 1.22 gram traveling horizontally at constant velocity 5 meter per second. It then enters an upward uniform electric field 3 kilonewton per coulomb. Okay, explain quantitatively with the aid of a label diagram the motion of the particle in the electric field. Okay, so this is about the uniform electric field. All right, the motion of the particle in the uniform electric field. Of course, because you need to explain quantitatively. So from the question, you just list the information given, which is where we have the magnitude of the particle, which is 4 microcoulomb, the mass of the particle, change to the SI unit, moving with the constant velocity, and the uniform electric field is 3 kilonewton per coulomb. So how to explain quantitatively? Quantitatively means you need to use the calculation, or you need to explain in terms of equation. Okay, so how? Referring to the situation, this is the electric field, upward uniform electric field. Okay, upward meaning that the positive plate is here and the negative plate is upward at this position, and E is upward. Okay, the direction of uniform electric field. Okay, and then if you have the particle initially enter with the constant velocity V, enter the uniform electric field. So what happened? So it will move. We need to identify the motion of this particle. So what happened inside the uniform electric field? This particle will exerted with the electric force. Okay, exerted because of this particle is positive 4 microcoulomb. So the direction of the electric force is towards the negative charge, negative plate, and of course the mg is downward, the weight of the particle, because the weight of particles is 1.22 gram. So downward directed, the weight is directed downward. So where is the direction actually? Where is the path, the motion of this particle? So to make sure that either this particle moving straight line or the particle moving to the negative plate or moving to the positive plate, it is depends on the magnitude of Fe and also the mg. Because of that, if we calculate, because we need to explain quantitatively, so we need to prove using the calculation. So if you calculate the electric force exerted on the charge on the particle, so Fe is equal to QE, we get that the force exerted on this particle is 0.012 Newton. And if we calculate the weight of the particle, so it is equal to mg. So m is 1.22 times 10 power negative 3 times 9.81, you will get 0.012 Newton. So the magnitude of the electric force or electrostatic force exerted on the particle, same with the weight of the particle. Because of that, what we can conclude, how you want to explain. This is the quantitative way to explain the motion of the particle. So you still need to explain. So your explanation is the particle will move in the straight line with the constant velocity, which is 5 meter per second. Why? Because of the magnitude of the electric force is equal to the weight of the particle. Okay, so from the calculation, we can prove that the particle move in a straight line with the constant velocity 5 meter per second. Okay, and let's say if the electric force is greater compared to the weight of the particle will move in the parabolic path. Okay, that's the example if the electric force is not equal to the weight of the particle. Okay, clear, right? So now we go to the question number 7. So for question number 7, point A and B are at the distance of 2 and 3 centimeter respectively from a point charge Q, which is negative 100 microcoulomb. Determine the electric potential at A and B. Okay, so now question number 1 to 6, we discuss about the vector quantity, which is electric force and also electric field strength. And for question number 7, electric potential is the scalar quantity. Okay, so in this case, we need to determine the electric potential at point A and B. If you look at this question, the figure is not given to you, right? So actually, no need, because of electric potential is a scalar quantity, you just need to understand how to use the equation for the electric potential. So the situation, if you look at, even it stated the distance from the point charge, so we just use the value only. And if you refer to the given information, I just list the information given. Okay, and then we want to calculate the VA and VB. So how to calculate? Okay, referring to the equation for the electric potential. So what is the equation for the electric potential? So the equation for the electric potential is KQ over R. So referring to the equation, we can calculate one by one, which is electric potential. At point A, VA is equal to KQ over RA. This potential is because of the point charge Q. Okay, so the potential also depends on the distance from that point charge. When we substitute, okay, in this case, take a look here. Just now I said for the electric field, when you and electric force, when we substitute the charge, we need no need to substitute the sign. But for the electric potential or for the scalar quantity, we need to consider the sign of the charge. Meaning that in our calculation, we need to substitute the negative 100 microcoulomb charge. Negative because of we not use the sign to identify the direction, right? Because of electric potential is a scalar quantity. Okay, so make sure that you to calculate the electric potential, you need to consider, you need to substitute the types of charge given. And the distance from point A is 0.02. So when you calculate, you will get that the potential at point A is negative 4.5 times 10 power of 7 volt. Don't forget the unit. And also at point B, we use the same equation, only replace the distance, which is the different distance, 3 centimeter or 0.023 meter. So you will get the electric potential at point B is negative 3 times 10 power of 7. Okay. So it is very, very important for you to differentiate between the scalar quantity and the vector quantity. For the vector quantity, because of the sign of charge, we use to identify the direction. During the calculation of magnitude, no need to substitute the sign. But for the scalar quantities such as electric potential, when we calculate the value for the electric potential, we need to consider the sign of the charge. Okay. So that's 7A. For question 7B, we need to calculate the energy required in moving a point charge Q positive 2 microcoulomb from A to B. Okay, what is the energy needed to move the point charge positive 2.2 microcoulomb from point A to point B? So to calculate this, okay, we have the concept, or before that, as usual, even it is a 7B, so I just list the information back. Or if you don't not want to waste your time, please highlight the hidden information that you get from point A and from calculation A, which is the VA and VB. Okay, maybe we can use it to solve 7B. So to calculate the energy required in moving point charge, so this energy is equal to the work done to bring or to move a point charge from point A to point B. Alright, in terms of equation, we write down that WAB is equal to Q delta V. Delta V is the potential difference between these 2 points. And in this case, because we want to move the charge from point A to B, or the work done from point A to B, so it is also equal to Q times with VBA. Why? Because of for the potential difference, point B final minus initial. Okay, VB minus VA. Okay, final minus initial potential. All right. So because of that, Q is positive 2 microcoulomb. We just substitute and do take note that micro times 10 power negative 6 when you press your calculator. And then you substitute the VB, which is negative 3 times 10 power 7. We just bring forward the negative. Don't ignore the negative, yeah? Because it is a scalar quantity. Work is also scalar quantity. And then minus with VA is negative. So substitute the negative also. And if you calculate, you will get that the work done or the energy required in moving that point charge from point A to point B is equal to positive 30 joule. Okay. This is the application, or we use the relationship between the electric potential, and then there is a potential difference, which is final potential minus initial potential, and also the work done or the energy required to move a charge from a point to another. Okay. And then we go to the question number 8. Okay, for question number 8, this is, if I'm not mistaken, this is the your partial question, right? Okay, for question number 8, 2-point charge Q1 given as positive 8 microcoulomb and Q2 negative 5 microcoulomb. Okay, I also write down in the information given here, placed at point X and Y respectively as shown in the diagram. So determine the potential difference between the point R and point S. Okay, potential difference. The question number 7, I show you the calculation if you want to calculate the electric potential at a point. Okay, now we just want to calculate the potential difference. So what we need to do, same thing. For the potential difference, you need to know the initial point, the final point, right? So you need to calculate first the potential at the initial point and potential at the final point. So for question number 8A, we want to calculate the potential difference between point R and S. But what we need to do first, okay, referring to the diagram given or figure given, so it is very important for us because of given here is point X and Y only, and we need to put the Q1 at point X and Q2 at point Y, referring to the question, right? So uh, before that, we need to know the distance, because of in the calculation we need to know the distance from that point from the charge, right? So in this case we have no distance from S to Y and R to Y, so we calculate first referring to the information given in the figure. So RSY we get, if we calculate 6 square plus 8 square set, which is equal to 10 centimeter. And for the R, for the distance from point R to point Y, the distance is 12 centimeters. So this is actually hidden information, the value that we will use in our calculation. Okay. Now we can calculate, because we have the R, we calculate the V at point, we put the charge first so that we will not confuse. Point X is positive charge, point Y is negative charge. Okay, the magnitude you can refer to the list of information there. And then when you calculate VR, so referring to the point R, to calculate the electric potential, not potential different, electric potential at point R, it is depends on how many point charge around the point R. So in this case, there are 2 point charge, which is positive and negative charge. So for the calculation, because of VR, V is a scalar quantity, we just add the potential. So the equation is KQ1 over Rx plus with KQ2 Ry. Okay, just plus. Doesn't matter. No need to consider the direction to the left or to the right. Okay, and when you substitute, now is important. When you substitute, plus, okay, take a look. Q1 is positive 8 micro and Q2 is negative 5 micro. Okay, and the distance is 0.09, referring to the given R from point X is 6 plus 3, 9, right? And then Ry from R to point Y is 12 centimeter, we have calculated here. And then you will get VR, which is equal to 4.25 times 10 power of 5 volt. And how about, because we want to calculate the potential difference between point R and S, so we need to have the Vs. So do you know how to calculate the Vs? Okay, referring to the VR, we do the same thing. For the Vs, because there are 2 point charge here, so KQ1 over RSX plus KQ2 over RSY, we just substitute the value that we have calculated. Okay, and you will get the Vs is equal to 7.5 times 10 power of 5 volt. So we have the VR and Vs. Now we can calculate the potential difference. Am I right? So for the potential difference, which is VR minus Vs. Okay, this concept is very important. Please refer to your lecture note. In your lecture note, I don't remember which slide or which page. So please refer. There is a one page explain about the potential difference and the work done. Okay. So in this case, to calculate the potential difference between point R and S, we get that 4.25 for the VR times 10 power of 5 minus 7.5 times 10 power of 5 for the Vs. So you will get the potential difference, which is equal to negative 3.25 times 10 power of 5 volt. Okay, so the calculation is quite long, but you need to be careful because of in calculation for the electric potential, we substitute the negative sign. Okay, all right. And now we want to calculate the 8b, the work required in moving a positive charge of 2 microcoulomb from S to R. Okay, 2 microcoulomb from S to R. Okay, how we want to calculate the work? Okay, in this case, okay, if you look at the information given here, I just write down the VRS that we have calculated in A, because of it will help us to calculate the work that required in moving a positive charge from 2 microcoulomb from S to R. Okay, so because of that, we will use the equation for relationship between the V and the work done, which is VRS, is equal to work done from S to R over Q. Okay, take a look at the subscript that we use. Make sure you use the correct subscript, represent the correct value. Because of that, to calculate the work required to moving a positive charge from S to R, it is equal to QVRS. And VRS we have calculated earlier, which is given us negative 3.25. We just substitute inside the equation and you will get that the work required to move the positive charge is equal to negative 0.65 joule. Okay, this calculation is very important, especially the sign, because of even the sign is not explained about the direction of the work, but the concept is there. You understand the concept of the scalar quantity and you can differentiate between the scalar quantity and the vector quantity. Okay. All right. Now we go to the question number 9. Okay, for question number 9. All right. Overall, we start from the electric force just now and the electric field strength. Then we go to the first two, electric force and electric field strength is the vector quantity. And now is the electric potential is scalar quantity. And also another terms that you learn instead of electric potential and work done, okay, or energy required to move the a point charge, you also learn about the electric potential energy. So these three terms, electric potential, work required, and electric potential energy, is a scalar quantity. So there is a difference in calculation for the scalar quantity and the vector quantity. So referring to the question number 9, from the figure given, if the distance D is 14 centimeter and charge Q is 150 nanocoulomb. So nano is 10 power of negative 9. What is the electric potential energy of this system of charge? Okay, so showing there are, if you refer to the figure, there are 3-point charge here, and then the distance from each other is D of 14 centimeter, and the magnitude given as, for example, Q1 is positive 4Q, Q2 is negative 2Q, Q3 is positive 5Q. So the Q is represent 115 nanocoulomb. So make sure that you alert about the value for Q, not the elementary charge, 1.6 10 to the power 19. So the given here, the magnitude is given here. So to calculate the electric potential energy, we will use the equation, okay, for the electric potential energy for the system of charge. So in this case, this is 3-point charge, system of 3-point charge. So the equation to represent the question is U, represent the electric potential energy, is equal to KQ1. Okay, electric potential energy, it is between the two charge. For example, between the Q1 and Q2, between the Q1 and Q2, and then Q1 and Q3, and also Q2 and Q3, between each other, but involve two charge each. So we just add on all the potential energy between these charges, and the distance is divided by the distance R lah between each other. Okay, when you substitute, okay, do take note the substitution, very important, yeah. So because of U, or potential energy is a vector quantity, a scalar quantity, sorry, a scalar quantity. So when you substitute the charge, for example, Q2, if you look at here, Q2 is negative 2Q, Q2 is negative 2Q, so we substitute the negative sign, okay. We substitute the negative sign, negative 2Q. Okay. And then for the Q1 and Q3, luckily both is positive charge. So we just substitute, I just write down the positive for you to remember. For the electric potential energy, supposed to substitute the sign of the charge. Okay, here between the Q2 and Q3, because Q2 is negative 2. So I just substitute the negative. Okay, and in this case, we just solve first, settle down, because it is quite easy. Negative 8, all Q2. So negative 8 plus 20 minus 10, it is equal to 2, right? So 2 Q square divided by D. Okay, now I just substitute. Our Q is 150 nanocoulomb. Okay, and the D is 0.14 meter. Do take note, nano is 10 power negative 9. So when you do the calculation, you're supposed to substitute, press times 10 power of negative 9, and then square the value, then times with 2 divided by 0.114. So because of that, when you press your calculator, you will get the answer for the electric potential energy for this question is 2.89 times 10 power negative 3 joule. So I just want to remind you, if you want to calculate the electric potential energy, it is doesn't matter how many charge. Actually, for the matriculation level, the maximum is 4-point charge in a system. Okay, so if you have 4-point charge in the system, you just need to write down the equation for the potential energy, referring to one by one. Okay, between the Q1, Q2, Q1, Q3, Q1, Q4, and so on, dan seterusnya, and so on lah. Understand or not? That's because it is a scalar quantity, and please substitute the negative sign when you do the calculation for the electric potential. Okay, and then no need to measure the direction because it is a scalar quantity. And now this is a application of the equation of the electric field strength, another equation that we can use to calculate the electric field strength. Okay, because of this is involve two parallel plate. Okay, for question number 10, two parallel plate are connected to a 120 volt, okay, battery as shown. Calculate the electric field strength between the plate. Okay, so it is quite simple, right? The given 120 volt, and then the distance between the two plate. Take note in the figure, given the distance between the two plate is 2 centimeter. So if you want to calculate the electric field strength between the plate, okay, the E, we want to calculate the E now. We have the V and D. So actually another equation we can use directly instead of the definition of E just now, which is E is equal to F over Q. We also have the relationship for the two parallel plate. The electric field strength between E is equal to F over Q. It is depends on the charge, point charge. So for the electric field strength, in this case, for the two parallel plate, we can use equation of, or we can use the relationship, which is E is equal to V over D. Okay, V over D. And in this case, V is 120 volt and D is 0.02 meter because of 2 centimeter. So here supposed to be 0.02 meter. So I substitute SI unit. If you calculate, very important, you need to change to the SI unit. Very important because of if you substitute 0.02 meter, so you will get 6,000 volt per meter, or you can use unit Newton per coulomb too. You can use Newton per coulomb too. Okay, if you substitute 0.02. If you substitute the distance between the plate is 2 centimeter, you will get the answer which is 60 volt per centimeter. 60 volt per centimeter. But you cannot use Newton per coulomb unit. Okay, why? Kalau if you use 60 Newton per coulomb, your answer is wrong. Okay, why? Because of the unit Newton is SI unit. So whatever you substitute inside the equation supposed to be SI unit. Okay. If you not change to the SI unit, your answer still correct, but with the unit of volt per centimeter. Okay, volt per centimeter. Please take note about that. So my advice is in any cases for the safety precaution, change to the SI unit. Unless you know you will calculate the ratio. When we calculate the ratio, normally we can cancel the unit, right? Above and below. So it is okay. But the rest, if you need to substitute in a equation, change to the SI unit. Use the standard unit. Okay? For the safety precaution. All right. And now for the, I think that there are another two questions, if I'm not mistaken. But okay, but it is okay. I will stop here. These two solution, I will share all of you the video for the solution for the two question that in my PDF. Okay, so we will stop our class here. Okay, so Alhamdulillah, because of the times as now 6 o'clock, right? So Alhamdulillah, with the God grace, we have reached the end of today's lesson. Congratulations to those who are able to follow our lesson from the beginning till the end. Okay, before we end our session for today, okay, everybody supposed to wait, right? I will announce the last digit code for the credit claim. Okay, so the last digit code for today's class is 4, number 4. The last digit code is number 4. So all of you, please stop posting your comment for a while and click the subscribe button and activate the icon bell so that you will not miss the next class lesson. Okay. Then if you find that the lesson was beneficial, please click like and share to your friends on your social media. Spread and share the goodness. Okay. And then once complete, please type done. Okay. On the chat box before the certificate link is given as the token of thank you for your dedication in joining this free online class tuition. Okay, today. Okay, I will put the link to for the certificate and credit claim in the chat box. Okay, wait, credit claim uh, link for the certificate and also wait, so you can claim your certificate and also your credit claim. Okay, have you write down all the credit digit, right? Okay, so make sure that you claim. It is a lot of uh, present gift for you. Okay, so uh, I hope that okay. Please use that link, to claim the credit. Okay, all right. So now, please take note that the link is there. Okay, so please take note the link will end half an hour after this live. Okay, make sure to use the EDD email and MOE email only to log in. Incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is already given in the chat box. Okay, so if you wish to get more information on the online classes, you can go to academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all of you for joining today's class. You are awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter too. So I think that's all for now. See you in another lesson. So remember the hashtag bermula percuma, selamanya percuma. So Assalamualaikum warahmatullahi taala wabarakatuh. Stay safe till we'll meet again next week, same day and same time. Okay? So bye. See you next week.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.